Special good afternoon, distinguished ladies and gentlemen, televiewers. You're welcome to this very fresh edition of your program CUIBR. Yes, we all know that the program comes up every Saturday as from 3:30 p.m. to 4:30 p.m. And we're welcoming you as we're broadcasting live the foot of Mount Cameroon. Yes, the foot of Mount Fako. We are here at the Divine Mercy Radio and Television Station. Yes, DMRTV. You are all welcome to CUIBR. And of course, on today's edition, we are going to be delving straight, yes, to this very important school. Yes, in CUIB, we are an Afro-American university. We deal with Afro-American system, and that's why we have schools and not faculties, like in the case of the English, system per se. So at the moment, ladies and gentlemen, we want to welcome all of you. And as you relax to follow CUIB this day, we are promising you to give you nothing but the best when it comes to information. And the legendary hospitality was situated beside Lycée Moliko de Boya. Of course, some people say adjacent, some people say opposite. We are just around Lycée Bileng de Boya, and of course just very close to Lycée Technique, yes, the government technical high school here in Moliko Boya. So you're all welcome. We shall be right back. When we come back, we shall get into the nitty-gritties of today's edition of CUIB. Stay with us.
I'm from CIB. Of course, everybody thinks our school is 1 million. Right. CIB, of course, this our logo.
I'm from CIB. Of course, entrepreneurship is favor more than other subjects.
I'm from CIB. Of course, they all think we are Ajabo. I'm from CIB. Of course, everybody thinks an iPhone is our school necessity. Right.
I'm from CUIB. Of course, our lecturers are the best.
I'm from CUIB. Of course, our school campus is very neat.
You're welcome back. Of course, these are students in the School of Health Sciences. Yes, he got them saying that people have different opinions of the kind of students who study at the Growth Mindset Entrepreneurial University, CUIB, yes, Catholic University Institute of Boya. And of course, ladies and gentlemen, it's time for us to get into our panelists, those who are going to be part and parcel of today's edition of the program. In the meantime, it's time for us to get information on this very great man who happens to be a member of the panelists. Of course, we're talking about Dr. Agbo Nerem Enyong Nyanket. Ladies and gentlemen, he was born in Limbe in the year 1975, obtained a BSc in physics from the University of Boya in 1998, an MSc physics from Umeå University in Sweden, and a PhD in electromagnetic modeling from Luleå University of Technology out there in Sweden in the year 2010. Dr. Agbo worked for Bombardier Transportation in Sweden, designing propulsion systems for high-speed electric trains for 8 years. He has been part of team that designated train propulsion systems on New York City Transit, San Francisco Bay Area, Chicago downtown in the US, London Underground and Cross Rails in England, Shanghai Line 12, Beijing Line 14 in China, Queensland Rails in Australia. Dr. Agbo also worked as technical consultant for Volvo Cars and Toyota Japan, where he helped out with vehicle electric propulsive system design issues. Dr. Agbo is home to give back and now is the current head of department for electrical engineering, School of Engineering, Catholic University Institute of Boya. That's a brief profile of a great man. And of course, you're welcome on board, Dr. Agbo Nerem.
Thanks for having me. This is a pleasure. And like I said, like you've said, it's great to be home again and get to work with the young ones and impact this knowledge development, make them have this mindset of designing designing stuff, electronics, driving the market, owning control of their own destiny, and leading the world of technology development.
Yeah, that was a great profile there, Doctor. I mean, you worked in all these countries. Had a lot of experience, and we're hoping that in the course of today's edition of the program, we shall be getting more on you. And of course, to my immediate right, we have this young gentleman, very handsome and very intelligent equally. Of course, his name happens to be Kate Joseph. A sophomore means second year student in the School of Engineering. So you're welcome, Kate.
Thank you, Mr. Oscar. I thank you for being here, giving this opportunity to express my light into the world, express my knowledge into the world about CUIB and my profession and my professional expertise that the school gives to me. I thank you for giving this opportunity.
All right, we're hoping to get more of you as far as the program is concerned this beautiful afternoon. And of course, to my right still, we have Femchak Bobuin Boris, BTech as students in the School of Engineering, of course, CUIB. BTech, ladies and gentlemen, will mean that, of course, the program after your HND, you have a BTech if you're not going for a degree program. So you're welcome, Boris.
Thank you very much, Mr. Oka. I'm glad to be in this wonderful program, although it's my first edition. I thank you very much to be here, and I hope that what I share with you is going to very much impact your life in this session. Okay,
in fact, the lives, of course, the listeners and, of course, the fellow students following, and why not those in the professional world following as we speak. And, of course, before we get into, of course, our engineering lab, we have lab here in Boya, the Boya campus, as well as lab here in the Douala campus. Doctor, you've had a wide range of expert of department, electrical engineering, School of Engineering, CUIB. What are the short-term goals, of course, of the School of Engineering, especially the electrical engineering department?
Okay. CUIB, School of Engineering, aims to distinguish itself amongst other universities in Cameroon. And its unique selling point is the hands-on skills for the students. So we are quite concerned about the state of things. Most things are imported. Electronic gadgets are imported. So we believe, and I think we have very intelligent students, and once we mold them rightly, they'll be able to design most of these products at home, and we become technology independent. That's one of the things, the biggest challenge we have. And I think we are touching it. Right now we have challenges with utility power, and we also have challenges with the development of electric vehicles. And around the world, that's what people are talking, discarding these normal combustion engines to start using pure electric powered vehicles. And at CUIB, we are really taking that core. We consider that as core. And in our courses in electrical engineering, there are various aspects there that give the students the hands-on to be vibrant participants or actors or entrepreneurs in this area of electrification.
Definitely. And maybe we make it clear. We have School of Engineering, a very important school in the life of CUIB. And we know that the world is changing. In fact, the world has changed right now. It's moving towards technology, moving towards the things, manufacturing and doing things unlike the case before. You see people, students, parents sending their children to schools that are meeting up with the current demands in the world, in the professional world right now. In the School of Engineering, can you tell us how many departments are there so that those who are following will know that CUIB covers a lot?
Yeah, we have electrical engineering department, we have chemical engineering, we have civil engineering, and mechanical engineering.
Okay.
Yeah, so there's 4 departments, and like the projects, the kind of challenges we have, like if you look at the propulsion system of a car, it's an interdisciplinary. These are interdisciplinary subjects, so that will involve the electrical engineers, the the mechanical engineers. And when it comes to other projects, it has to do with houses and so on. That will also involve the other departments. So we work in serious collaboration. Some courses go across the different departments.
Okay, very interesting. We shall be getting more on that in the course of the program. I wish to find out from you, Kate. Could you tell us about the life in CUIB so far? You are sophomore, this is your second year, and possibly how the School of Engineering is preparing you towards the professional world.
Thank you. As our Dr. Agbo explained earlier, Cuib University aims to distinguish itself from other universities. The School of Engineering, we tend to do this in aspects like he explained, like getting hands-on knowledge and hands-on activities. Our studies is loosely based on theory. More hands-on, more practical. We do this lab experiments, lab activities, lab exercises. We have trade fairs that we showcase our expertise and our knowledge that we've been taught. So Cuib University, prepares a student for the professional world as a whole. Builds you that entrepreneurial aspect of a person. It brings it out of you. So it really do stand out from other universities in that aspect.
Okay, Boris, this is your third year in the Cuib University Institute of Boya. How was your experience at the HND level, HND School of Engineering?
Well, actually, this is my first year in Cuib University.
Okay, Cuib University.
Yes, I just came in for the BTEC. I had HND somewhere else.
Okay.
But before I came to Cuib University, I actually did some research. And in addition to what my fellow coursemate Kate has said, there is a notion in the community now where people have that after you leave school, you cannot get a job or you cannot find something to do. But this CUIB Institute is so wonderful. It has found out the exact problem that we have in our society today, and they have found out various ways to break this problem, to renew the mind of our youth in our society today so that we can go further from this problem. And one of the ways CUIB has brought up to start up to change the mind of this to change the mind of our youth nowadays is the entrepreneurial studies. They have a very good entrepreneurial system that helps to build the mind of our system educationally, and they also have programs like the trade fair where all workshops come up and they display, and students see various things that they can do even if you are not you have not yet found a solid ground in what you were meant to do. And about the life in CUIB has created a system to make life very easy and very simple for students on campus. Like we have a canteen which is on ground. We also have printing press which is on ground. We also have other things like EOCR. EOCR is a special time dedicated every day in school to build the CUIB student spiritually. So CUIB has come up with many ways to break the Cameroonian youth out of this issue of unemployment and sometimes some people say laziness. We say the youth are lazy, but CUIB has come up with a way to change this.
They're very interested, of course. Boris there with, such experience, of course, clarifying us that he's coming to CUIB. This is the first year. He has been in another university. That's where he obtained his HND. We are very, very glad with that update. And we know that CUIB, just like he mentioned, is doing things differently. It's growing the mindset of students and being very entrepreneurial. Ladies and gentlemen, Doctor, I think it's time good enough for us to see. Let's get into the lab. Let's see some of the things that we do at the level of this School of Engineering, Electrical Engineering to be precise.
Okay. This is power electronics students in the lab displaying some stuff that they have built. I don't know, Emerson, do you want to explain what you're doing here? I see some circuits on the breadboard and some LED. I think there's some transistor there. Can you explain to us what this circuit does?
Okay, sir. This circuit is used for dim. The circuit is used for light intensity. The circuit is used for light intensity control or dim control.
with its maximum voltage being 2.5 and can be adjusted from 0 to 2.5 using this. So that's...
So when you adjust the voltage, the LED lights, right?
Yes.
Okay, go down, okay. Increase it to like 90%. Let's see. Your hand is covering the LED. Okay, yeah, now it's brighter than so it's 90% to the side. So what other application can you use this? I think you can use this for motor control as well. And there's also much more complex design right here. I think it's motor control. Kate, you are second year student. I can see, I think it's a DC motor or something, and some transistors. And can you explain to us what that circuit does?
So this circuit is we're trying to control the speed of this motor, giving it variable speed. So we do this by controlling the amount of voltage that the supply that the motor receives. At this moment, we are giving the standard supply is standard 8.77 volts to our gate drive, our transistor that controls this voltage. So let me switch the circuit on. See that the circuit comes on. So at this point now, we do this by each transistor. We supply a signal to it. This signal gives us the frequency that once the motor will rotate that and the amount of voltage that it receives. So at this point, at this moment, the motor receives only 40% of the voltage that is sent to the circuit. And now we use the duty cycle. That's the amount of voltage that it receives. So you see that when we reduce this duty cycle, the speed of the motor reduces, and the torque when the voltage reduces.
Yeah. And your oscilloscope is displaying some signals there.
It displays the signals that is received by the voltage that is going through this motor and the voltage that is coming from this signal generator.
Okay, the signal generator, that's the signal controlling one.
I think if you can look closely to the oscilloscope, you see that our signal generator is on average 4 volts.
Okay.
Yeah.
Okay.
And average that is being received by the motor.
Okay. Okay. And I see that we have negative voltage. I'm sure that when the motor is braking and it has more energy, so the energy goes back to the circuit. So that's why we have negative voltage. Right? Very interesting. But which other applications can we have this circuit?
This is speed control. Also is in torque control. Here, let's say for example, we want to control let's say a grinding machine. Now for a grinding machine, let's say small amount of load, you need smaller amount of voltage so you can save power. So instead of you just putting your grinding machine switch on and gives you that amount of voltage.
So not full power all the time.
Not full power.
Small power.
Let's say you have your small paper and you grind. You use less power, and use less voltage.
You save energy.
Save energy.
And energy is more.
Less power. Yeah.
Okay.
Grinding machine, blender also. Yeah, guys in the blender, guys in electric cars.
Electric cars.
Electric cars. Yeah. So this varying speed, varying torque, varying voltage of the motor has diverse.
The electric car is quite interesting because then you see the car, it has different weight.
Yeah, that's the same
when it's full load and you can change the speed. So you can use the same kind of circuit to control the speed of the car. Okay, very interesting. Thank you very much.
So I think I can show you, first of all, before I ask you to design all this, I have to simulate.
Okay,
where's the circuit? This is the circuit. This circuit that is that has to.
So that's
So this is I designed the circuit first, then I now run it for my test. This is the oscilloscope. This is the device that I show you. You see the voltage that goes through the motor. This is the same.
We have L1 there, that's the motor and the diode, right? And then the upper part is the transistor. and then you drag it.
This is a gate where our signal comes from this guy.
Signal generator, that's what you do, and then here you start your power, you and the power supply. Okay. So you first of all do your simulation before you come and build it. And do you have good correlation between your simulation and the real life?
Yes, you see that there's this blend. It's like a direct relationship that you have. You cannot just do this without actually knowing where you're going to. Like, you have to at least visualize the end of it before you can really start doing the so that's what we use the simulation to do. The simulation to do.
Okay.
So we get first, then now we practical.
So you mean that most of the stuff you want to do, you have to simulate first?
Yes, to get an idea, direction.
But if you don't simulate, what will happen?
Well, you can have an error and you not know where your error lies. From the simulation, you know that if, let's say at all, I'm imagining that this is how the circuit was supposed to come out. Let's say I start having like funny
waveforms.
Yeah, funny waveforms on the oscilloscope. Like you saw the transient there. Maybe from then now, or I might think that maybe that's the reason of which that's not it. So from here now, we can answer particularize now our errors, how to reduce that transient and all those things. And we could not have known those errors without the simulation. So,
Alright. Yeah. Interesting.
You said this is department?
Electrical engineering, and this is a course, power electronics.
Okay.
And power electronics, and there are also students of basic electronics, basics of electronics. And our focus here is on hands-on. We want to make
Focus
sure
on what?
hands-on.
Hands-on.
Yeah.
Okay. Hands-on.
Yeah. So the students, they should be able to conceptualize something, simulate it, build the prototypes, and make it work. Because we are looking forward to graduating designers of electronic circuits. So, and this is kind of the basis, you know. So, yeah.
Okay. At this point in time, we should find out. Thank you very much, technical team, for taking us to the lab, School of Engineering Lab, CUIB. Doctor, that was a great one there. And, we're at the level of there's a power electronics lab. With engineers, you must be able to use their terms, of course. For more indications, you as an individual as well as in collaboration with the school had to make sure that we had such a platform for students to improve on their hands-on. So how has it been so far?
Well, so far so good. At least we have the equipment there, and of course we would like to have much more. We are looking forward to building a CUIB electric vehicle with a nameplate CUIB. So it will just be an advanced version of what you've seen there. So instead of having the small motors, they'll have bigger motors.
Bigger motors.
And then the electronics now will be able to carry more power. So the theory and the hands-on they have there, they can just use that. But then high power, then you need to be, maybe the safety will be more critical. So it's a good base. And I know I say it very proudly, we are second to none. Yeah, it's a small university, but because if you go comparatively around the world, those big universities like in Stockholm or US, Wisconsin University, which is very famous in this power electronics design, the lab is what is the oscilloscope, the signal generator, and the power supplies, and your computer. So we have those basic, and the students have it. And we're hoping to get more of those, so that because it's hands-on, so it's like playing a guitar. So you need to be having access quite a lot to really enhance the skills. So that's fine. And we're thinking that our students would be able to compete with students from anywhere in the world, even Japan. So because the theory is there, same theory, we see it, the computers are available, we can model, and we can measure and build. The components are there, we get them anywhere in the world they're found. So Yeah.
All right. So these are the efforts, of course, that CUIB is putting in to improve on students' hands-on experience.
Correct.
Very interesting.
Yeah.
And of course, you saw yourself demonstrating knowledge on. I got, of course, from that feed. Kate, you were talking about grinding machine. Talking about this is, I mean, this, I'm sure this is you were building the prototypes and the drive systems, but probably those out there watching right now, especially those who are interested in the School of Engineering, maybe you want to explain a little bit or summarize what you're trying to do there. What was happening there, so viewers get to understand.
Okay, that particular lab experiment that I was trying to do, I was trying to control the speed of a motor. You know, the motor, when something attached to it, that force that drives the motor, the force that drives the motor is called the torque. That's the torque. That means, so when controlling our speed, now tends to control the torque of a motor. That torque now is what you see now in a blender. That sharp thing that spins around here. That's the torque. That's the torque that spins that thing. It's a torque that also drives, let's say, a toy car. A toy car where you pull it's a toy that propels its tires. So what we're trying to do is that we're trying to control that speed of that motor. Instead of giving it a constant speed that should just flow at this particular speed, at this particular amount of power. So now say that why should we give that constant speed that should flow an amount of power? Then let's say it uses now maybe excess power for when it does not even need. So we're not trying to control that speed now, you know, supplying it less amount of voltage so that it can now economize our power that we use our home, our electricity, all those things, you know, we pay less bills. You know, so it's more feasible economically. I don't know if you, it's more feasible economically, you know, more feasible economically, you know, it's also more technical, it's more advantageous for you to being able to change from one speed to another. So yeah, that's the main aim of our experiment. That's the meaning of our experiment, trying to now change that speed, not to give you that constant speed. That's why we call it a speed drive. The speed drive, with driving speed, voltage, and torque. That was the main purpose. We want to control those three factors because those are the three driving factors that actually have in a motor. Like our doctor explained that our plan is to create that CID electrical. Normally, the aim for that is once actually create that electrical, it's just the same thing I've seen here, but no, it's on a more complex scale. You know, since it's a car, it's normally going to need more power, so we normally need more complex battery cells to store that amount of power. We have that here. I've done this experiment before. You know, I did that last actually. My first storing capacitors, charge, all those things. So we need now battery cells that can store that power. We need a motor that can can spin the torque, the amount of the tires that we want, that force that we want for the car to move. That torque, that we need a motor that can do that. And we also need a good speed drive concept, like what we're doing here, that can control that motor, the speed of the motor. So we let's say forward, stop, all those things. So yeah,
very interesting. And of course we know that many are parents watching right now, many are students who are in upper seat examination classes. You know, they have started writing the mock examinations. Right, very soon is the GC, so there's no time. This is the time to make up your mind to be like Kate, who wants to improve and wants to be, by the time it gets to, because we have freshman, that's the first year, sophomore, that's the second year. We have the junior year, that's third year, and then senior year. That's before he gets to being a senior year student. I'm sure you already maybe have produced a car. We're not talking. You produce a toy next year when you be in your junior year, and a car when you be in your senior year. Amen. And of course, to you, Boris, we wish to find out from you. Given the electrification issues, of course, of the world right now, sooner or later, our roads definitely will be full with electric cars. That's what the engineers, the information, that's IT people, they are trying to do nowadays. And how does the School of Engineering, of course, prepare you towards this goal, this great challenge coming up? Have you seen a situation where, sooner, as in very sooner, we'll be having electric cars plying our roads?
Thank you very much, Mr. Oscar. Well, one thing I'd like to say now is that Cameroon is not a baby to electrical power systems.
Okay.
We have electrical power systems, we have dams, we have interconnection grid, we have high voltage power systems. But one thing my lecturer made me to understand here is that most of these systems are old. Most of these systems are outdated. So one thing the CUIB Institute is bent on doing is making a renewed system, bringing a renewed syllabus, bringing something new to the board of Cameroon. Because when they say electric cars, electric motors and all these things, these are new systems that the world has incorporated into their environment that Cameroon has not yet brought. So that's one thing that CUIB is focusing on, bringing these new systems, bringing this new technology into the platform of Cameroonian system of technology.
Very, very important. And of course, there is this myth that, the ladies, women, they are not involved in in electrical power systems, involved in they are not involved in the world of engineering and all that. But it will shock you because we have our students, female students in CUIB, we have female professionals who have gone out there who are doing things very differently. In CUIB, one of our goals is to train job creators and not job seekers. So we shall now be going back to the lab and maybe see if we have a female who is equally going to be expressing self in terms of what her hands-on experience, doctor. So let's go back to the lab and see what CUIB School of Engineering has for us.
That we use to display our signal and measurements. And here is a nice prototype in the mechanical engineering department that I talked about the collaboration that the school has. So they have something that designed this prototype. It's a heat exchanger, like an air conditioning, and there's a pump in there. And the electrical system will be handled by the electrical engineering students, while the mechanical engineering students realize this is just a review that we're going to do more realistic. We're going to do a more realistic put of all of this with onion sheets. Similarly, we have this here, it's a staircase, automatic staircase rolling. So it's designed by the mechanical engineering students. It's what we're going to do. We're going to use metal sheets, design this. And the electrical engineering students are going to choose the motors and control the motors. This one is an automated staircase that was like seen in the airport and so on. And this similar kind of system you can use to design a lift to take you to the fourth floor or something. And this will be a combination of civil engineering, mechanical engineering, and electrical engineering.
Okay.
And there we have still one more prototype from mechanical engineering students. This one is supposed to be, I love this one because I love food, and this is a coconut milking stuff.
Okay.
This is the coconut milk is out here. And they have to design the nozzles inside the mechanical engineering students. They will do this metal work with the nozzles and the formats and stuff like that. And the electrical engineering students will design the power system. So to control this one. The temperature regulation and things like that. So there's enough room for us to cooperate on this.
Of course, it's one school, so there's that need for cooperation all the time.
Yes.
We have one thing in common, and that is engineering. Okay, sir. Any last words, especially for those watching? Maybe there are things that they need to get briefly on what CUIB is offering and how CUIB has been improving to improve on the growth mindset that we preach every day.
Yeah, I want to say that the students in CUIB in the engineering department already have limits. They will be quite competitive. So students who come from Japan, USA, whatever, should be able to be challenged, easily challenge by students from here because they have the resources to do that, especially when it comes to electrical engineering. And we are looking forward to realize the project to electrify the car with CUIB named back, driving on the street of Korea. So that way we will actually let the car talk for us. So we will just be the student designing different components of that car. So we're just going to get a whole technical and electrify and let go on the streets. Once we do that, we just kind of maintain our position as number one, right?
The question you asked about what CNB offers is that here it's not all about theory and copying of notes. That is important, but more of practice, especially in the school of engineering. So when you get out there, especially in our society nowadays, it's not all about what you know in your head. You actually have to see what you can do. So when you get to practice all of these things and have the handwork, like even if you leave school and you're not working for somebody, you can get yourself self-employed. So that's what CUIB offers, the mindset of entrepreneurship. Like you think out of the box, you're not so limited.
Okay, so that's the added value.
And also, you asked a question here about if an engineer, like all of us here have our specialties. We are specialized in electrical engineering, mechanical engineering, civil engineering. You asked a question if you can work alone. Yes, you're specialized in what you're doing. But even have to see, even the building we are in now, the building was made, or like the idea of the building came from the civil engineers. But after they do all of that, you cannot have a building without the lights. That's what the electrical engineering comes in. And other things, the chairs and all of this, you have the mechanical engineers and every other thing. So a whole building is the combination of all this. And that's what makes engineering so creative, because you get to work. And you see how some people, they merge two programs, like electrical engineering and computer engineering. That's what I am doing. So just imagine you knowing two of these programs is so beneficial to you in the world.
How do you do that? I mean, how is that possible on you? I mean, isn't that weighing on you? Electrical and civil, right?
No, electrical
And computer engineering. I mean, it doesn't weigh down on you?
No, it does not, because even electrical engineering has a lot to do with computing and simulating using the computer. So you doing electrical and computer engineering just blends the two of them together and makes you somewhat different.
It's more competitive as well. You become more competitive.
And you have more to offer than somebody that just does one.
Okay. You have an added value of what you're doing, maybe as compared to other mates from other universities. Have you discovered any difference with you? And what are you training at CUIB?
We program this microprocessor. So there's a blend
social media that is going to see all those things. So you see how you blend this soup.
You are now put on.
Yes.
Fine.
So some more commerce than other universities. And I think the not like that other universities are not hands-on like this. Because I think I've heard about everybody from online universities that from other universities, other engineering universities, they do all these things, they're visualizing it, fractionalizing it, making it more practical, more conceptual. To them, it's just theoretical. You have to read, so you can. I think from what I said, there's some concepts that when you're saying like you cannot understand it, but when you try to make it practical, it's not only giving you that methodology, it's really giving you that more profound understanding. So that's what I understand.
Very important.
Sabo, do you have some comments?
Okay. You're level 1. Yeah, you just came in. School of Engineering. Thank you so very much for taking us back to the lab. There's a big laboratory for students in the School of Engineering, just like we have for students in the School of Health Sciences. IT lab is there equally. We have agricultural farmlands, and so we have a platform where students are given hands-on experience. And of course, the School of Journalism and Communication, we know that we have platforms like TMR TV, the radio and the television. We have Gori Martins, in partnership with Gori Martins. They learn how to do videographing, video editing. There are lots and lots of platforms. In the School of Journalism still, we have the Calic Cameroon Panorama, lots and lots of areas where you have to exercise. We have the printing press, just like Boris mentioned. Everything is in CUIB. So if you want to experience, you want to, of course, make yourself to be a job creator, you are very much welcome. Just to remind you that we have programs in the School of Agriculture and Natural Resources, School of Business, School of Information Technology, School of Engineering, various programs. And of course, we have the School of Health Sciences, very, very important. We have the School of Journalism and Communication. We have the School of Arts and Education. And why not the School of Law? We have HND, academic unit, where we have all sorts of programs in the HND level. So please, why not? Join the team. Join the Growth Mindset Entrepreneurial University and have another mindset out there. So right now, Doctor, we've heard and we've seen for ourselves, televiewers, that we have women who are involved in engineering. We saw the very young Eposi Brittany, who, of course, is a level 1 student. Is her first year in the School of Engineering. And of course, we know that she has given us an idea that you don't need to be in your final year to start doing things. So, Doctor, how has the training been so far? What are some of the challenges you faced? Going about this is not easy. We know that the Dean, School of Engineering, Mr. Epe, is watching right now and understanding that this is what's up. So what has been some of the challenges, especially with the practical aspects, which we find very, very, very dear to our hearts?
Yeah, I can say that this program, the electrical engineering program especially, is becoming very, very interesting to the students. You get feedback from the students. So we should respond to the students. So it's good that if he's watching, it's fine. So that we now they are, the lab is good enough, but we want to add more equipment so that we can meet more challenges, technological challenges. That's the thing. And of course, money is not just there.
Exactly.
Money is limited, so you need to always sell your case, and that we're trying to do. We are confident that the students are getting very competitive knowledge, and they're going to get the best if we look around. And the students are going to talk for us. Because when you see them, they tell you, oh, thank you, I'm very happy today for this. So when you as a lecturer, when you get those kind of feedback from your students,
it encourages you,
you feel very
motivates you, and you feel like, okay, you're doing it, and you still you don't need to relent. And we know we have different departments in the School of Engineering, CUIB. We have electrical engineering, civil engineering, mechanical engineering, and of course, chemical engineering. You are electrical. Of course, you are electrical equally. Yes. So, this other department, I mean, let's begin. Are there high demands for some particular departments in terms of this engineering program? Like in the world, does the mechanical engineering maybe graduate sell more, or better still create more out there, or is civil engineering the same? I mean, we want to understand it. Does it mean are we in the same platform? Does it mean the same thing? All these different departments, is one having an edge over the other, based on your experience so far?
I actually put a demarcation to that, because you see that, for example, our own Dr. Agbo, he has PhDs in mechanical engineering, PhDs in electrical engineering, and if he wants to go further, he also have a PhD in civil engineering, depending on what he wants, depending on the kind of future he wants to be for his life. So what I want to say now is that there is no demarcation. Everything is connected. Like they say they want to be we want to be an electrical car. Not everything will always be electrical. There must be parts of the car that will always be mechanical, depending on what we want, because it's a car, it will always be a car. So there must be things that want to be mechanical, and there are some other things such as the digital side of it, which we cannot neglect. That's electronic engineering that's also been incorporated into that. And also, when we are talking about building a house, if you want to build a house, you have a lot of civil engineering there, and at the same time you have an elevator. That elevator is also a sign of electrical and power electronics that have come together to produce wonders. We also have innovations like the crane, the high cranes that carry loads. These are mechanical and electrical systems that have come together. We also have things like the quarries, where we grind stones. Electrical and mechanical come together. So a lot of times you see these various sectors coming together to produce things. Even in the thermal power station, the uranium power station, you see chemical engineering coming with electrical engineering, coming with mechanical engineering, and even the house coming with civil engineering. So all of these things coming together, producing wonders in our society today. So you cannot actually put a demarcation to that. That's what I was saying.
Very important. You have an intervention?
Yeah. Actually, I'd say that maybe I think that in equal demand in the society, because I don't think one can live without the other. Because engineering initially is
so there's a symbiotic relationship
because there's this aspect of engineering studies they call mechatronics. Mechatronics is a blend of mechanics, electrics, and computing. So you see that's already like three different aspects of engineering that are really coming to one, and you see that this particular study they also implement it in civil studies, building studies, concrete studies, like this stadium that they use all those things. The kind of machine that they even use, all of these things. So you see that at one point in time, all aspects of engineering, they come together. So there's that equal demand for them. I don't think one can live without the other.
Very interesting. Doctor, you are.
Yeah. I think the students, they are pretty much on the stuff. Okay. I think it's very symbiotic. This is the whole issue about particular subjects. We're meant to make people have specialization, so that at the end of the day, you can have good engineering projects. But like the mechatronics case, you see that you have to put them together for them to work. Sometimes, like the FOC said earlier on, if you like to do electrical engineering plus computer and stuff, so that you can be like two people, that kind of thing. Yeah, but the challenges are there, and is I think collaboration is what you will really encourage.
Collaboration. So there can one be 2, 3, 1?
Yes,
it's possible.
Yes,
can be an electrical engineer.
Yes,
can be a mechanical engineer.
Yeah. I did physics, computer. I'm physics. I I'm a mechanical engineer. I did a master's there, and then electromagnetics, electrical physics. So I mean, for me, those things are. I don't differentiate them as such.
Okay.
I attack the problems.
Definitely.
So when I have a problem, I try to see what tools do I need to solve the problem. You see, then eventually maybe somebody might say, oh, electrical engineer, okay, no, I don't go and see this mechanical guy. But that's okay, let's try to make a model of this mechanical system to see how these vibrations come about.
Very, very, very interesting.
I would encourage the students to not overlimit themselves.
Okay.
So they
you have to be all round.
Yeah.
Be jack of all trades. Be like the journalist that will be what? The broadcaster, will be a technician, will be a publisher.
Yeah.
Because, I mean, someone who writes, you broadcast. At the same time, you're a technician. You know, at the same time, you produce. So, that's how you...
And the gadgets are becoming available now for you to be able to do that.
Do all that, yes. So you have to be all in one. So that is it. And CUIB televiewers, we make sure that we meet up with your dreams. And you watching, we know that you're following, and we know that very soon you shall be part of the Growth Mindset Entrepreneurial University. Ladies and gentlemen, we take on a brief break. When we come back, we shall be cutting the I's and dotting, that's cutting our T's and dotting our I's as far as the program CUIBR is concerned. Stay with us.
I'm from CIB. Of course, everybody thinks our school is 1 million. Like,
CIB, of course, this our logo.
I'm from CIB. Of course, entrepreneurship is favor more than other subjects.
I'm from CIB. Of course, they all think we are Ajabo. I'm from CIB. Of course, everybody thinks an iPhone is our school necessity. Right.
I'm from CIB. Of course, our lecturers are the best.
I'm from CIB. Of course, our school campus is very neat.
Thank you very much. We have, of course, all that in CUIB, especially the hands-on experience that we impact in students for them to be job creators and not job seekers. As we round up with today's edition of CUIB, I will have some last words from, we'll begin with you, Kate. Yes. Your mates are watching you out there, your friends, your neighbors, your family members, parents who equally have stake in this whole educational family. So I want to ask, what message, last words do you have for those watching, especially with your hands-on experience as far as UIB is concerned?
What's expenses that no, maybe you might be studying in different universities that don't have access to all of this, have access to the thing that I've shown you for this afternoon. So I want to say that whether you're wherever you are, whether your studies is mostly based on theory and mostly based on practical, you should try to find ways to balance the two. Try to give yourself an edge over the other. It's like an added incentive that you have into the professional world. So yeah, so try to balance yourself. Give yourself a balance. Yeah, between whatever it is that you think that you have to venture into. Yeah, so try to find a balance between that. Between those two, or most people, like me personally, you're asking if someone can be 2 in 130. I'm 2 in 1 now.
Okay.
Yeah, like what
the level of sophomore you're 2 in 1. I mean, by the time you get to senior year, you'll be like 4 in 1.
Yeah, 4 in 1. Yeah. Like I think now, what I was trying to explain in the video, that setup that we're trying to control that motor, the speed, the torque, everything. You see that if I thought was to realize it in let's say a blender, or you say you not take all those big devices, all those things, and understanding that you want something minimal, something idealistic, something small. That's where we now bring into place this microprocessor. That's computer engineering. In here now we now program microprocessor, give it the signal that wants to generate from external generator, give the particular signal, particular voltage that we want, the particular drive signal that we want for that motor to function at that particular torque that we want. So you see that there's that blend. We program, give out, then the electrical part now blend. So there's a balance that I'm just trying to find. I'm not saying I have that balance, but I'm trying to find that balance. And I think I'm on the right track. So my message is that wherever you are studying, you should try to find a balance for yourself also.
Very important. And of course, last words, Boris. I mean, you have lots and lots of people watching you right now. What do you have to tell them, especially with the fact that, you're a student in the School of Engineering, the Department of Electrical Engineering? Your last words for the viewers.
Okay. Well, I'd like to tell everyone who's watching me right now is that we know of very famous people such as Thomas Edison, Albert Einstein, Isaac Newton, and the great exploits that they have made in the world. But one thing I want to let everyone understand is that their exploits was practical that came to theory. It's not the other way around. Practicals that came to theory. So now if you are studying in any place, any other university apart from CUIB, and they are not giving you enough time of practicals, I would like to advise you that you need an extra form of work that is going to give you more practical, more insight into the things that you do. Thomas Edison invented the light bulb. He did countless experiments before he came up with that particular result. So I just want to give you an advice that the practical side of things is very important. I've been in other universities myself, and I want to tell you one thing. I don't want to judge, but I want to tell you one thing, that CUIB, when it means hands-on, it means hands-on. Every student gets an opportunity to do exactly what is required for their course. Every student, even the least, every student gets an opportunity to participate. So that's what I would like to share.
Thank you very much, Boris, and we hope that the message has gone through powerfully. Your last words, Doctor. I mean, it's not a new avenue for you. You are familiar with CUIBI. You're familiar with the environment. So, your last words for our viewers.
Well, I think the message is clear. To those who are still thinking where they're going to get their university studies, those who are in high school, you have to answer the question, what do you want? Do you want hands-on? Do you want to build robots? You want to build electric cars?
You want to build motors?
Build motors, build engines of airplane. If you want to do those kind of things, then the choice is yours, CUIB. And I think that our facilities, I'm sure we could be open for visits. So parents could come sometime. We'll see how to plan that. And I think it's we've been talking about it, but it's good that we see. Or we have like the BTech students, they are engaged in some projects at the end of this. It will be July. So that will be very interesting to run on TV, because they are really doing, I mean, they really have advanced product that they are manufacturing, they are designing, and probably do a prototype ready for the market. So, with that, I think I want to thank everybody for having time listening to us, and we always think we'll provide you the best. Trust us.
For sure. Try us, and definitely you trust us. That's Dr. Agbo Nerem, of course, from the School of Engineering, head of Department Electrical Engineering. I want to thank all of you televiewers for being fidel to DMR TV, for being fidel to the program CUIBR. If you did enjoy the program, catch us again next week. That's next week, Saturday, where we shall, of course, be getting to another school. Yes, we make sure that we give you the best when it comes to what we offer at CUIB. Special thanks to the Chancellor, Pro-Chancellor, who doubles as Bishop of the Buea Diocese, His Lordship Bishop Mike Bibi, for ensuring.
It was first a dream, later a vision, and today reality. DMR TV, Divine Mercy Radio Television. From Kumbo to Bamenda, Manfei to Kumba, to Boya, and the whole of Cameroon, we have a common objective, sharing the light of hope. DMR TV. Religion, news, documentary, sports, culture, and entertainment. A TV channel of the Diocese of Boya, broadcasting via satellite, cable, and streaming. Be one of ours. Join us. Divine Mercy. Mercy Radio Television. Sharing the light of hope.
Good afternoon and happy weekend to you, dear televiewers of Divine Mercy Radio Television, and welcome to our weekly program, Journeying with God's Word, every Friday, 3:30 p.m. to 4:30 p.m., wherein we bring to you key things of items that will help us clarify our doubts and also help us to have a better interpretation of the scriptures, the Word of God. Last week, or all along, I've been treating the figures of speech, but last week we did the figure of speech number 17, which was idioms or idiom. Today we shall be taking on board the 18th figure of speech, which is repetition. These are all figures of speech which are being used in scriptures to help us to, which we need to know in order to better appreciate and interpret the Bible. Straight away on my left, we have our usual resource person, who is Father George Ngomba, proper pastor of Christ the King Parish there in Movange in Tico. We say, Father, good afternoon. Happy Easter season and welcome once more after 2 weeks.
Father, thank you for welcoming me again during this octave of Easter. We could not be here because of the Good Friday ceremonies last week Friday. Today we are out to do our best after 2 weeks of rest. Thank you for welcoming me, Father.
Okay, it's always a pleasure to have you on set here, Father, to give your biblical know-how to the people of God, our viewers from far and near, home and abroad, to help them so that when they pick up the Bible, the Word of God, the Scriptures, they'll have a different look at it, unlike when they had not yet perhaps followed us on this program, Journeying with God's Word. As it is there, the topic is on your screen, figures of speech in the Bible, number 18. That is an error. It should be number 18, not 17. 17 was last week. Figure of speech number 18, repetition, which has to do. Anyway, let me not let the cat out of the basket. We'll always get to Father. As is customary, Father, we always begin with the meaning of a figure of speech before we go to the nature or the reasons for the repetition that are found in the Bible regarding figure of speech. So, straight away, what is this figure of speech number 18, repetition, Father?
Yes, Father, before I give the meaning of repetition, I would like the audience to know that it is a very easy figure of speech. Is one of the easiest in the scriptures and does not need a lot of concentration. I ask them to relax and have a nice time. By the end we finish, everything will be very, very straightforward. Looking at the definition, repetition means using the same word or phrase more than once in a text. Using the same word or phrase more than